Hey everyone, I'm Ayush, an undergraduate at lovely professional university in India and a research associate of the Blue Marble Space Institute of Science. I'm going to talk about our work on simulating chemistries that may help uncover organic compounds in carbonaceous meteorites. The problem is that although a lot of organic compounds that are found in Earth have been reported in meteorite samples, a lot of organic compounds in those samples are yet to be identified. So we created a model to guide future searches for those unknown compounds. For that, we used MOD, a graph theory-based tool, and we simulated two reactions, alkaline degradation of glucose and the Foremost reaction. So we start with a set of initial reactants and a library of reaction rules. Reaction rules are templates which dictate how a reaction is supposed to proceed. For example, this is a rule for the aldol reaction. We apply these reaction rules to a set of initial reactants. We get a set of products, and we filter out any bad structures in these products. And we call this strategy of applying rules to the reactants a generation. After a fixed number generation, we arrive at a final set of molecules, and we dump them. This is how the Foremost network looks like at the end of two generations. To test the accuracy for simulations, we checked if our network was producing molecules that have been reported in analytical studies in the literature. We also compared with high-resolution mass spectrometric data that we collected at the National High Magnetic Field Laboratory. We were able to match 96% of the molecules reported for glucose degradation by Yang and Montgomery, and in the case of Foremost reaction, 100% of the structures reported by Decasware and Almanidol. On the left, you see some of the molecules that we matched for the glucose reaction, and on the right, you see some of the molecules that we matched for the Foremost reaction. Apart from this, we were able to account for many of the peaks in the high-resolution mass spectra that we collected. All of this suggests that our simulations accurately represent real chemistry. Currently, we are trying to extend this workflow to include nitrile and amide chemistries and are also comparing them with similar data. We would like to acknowledge the Blue Mobile Space Institute of Science for the Young Scientist program, which allowed a lot of us to work on this.